Good morning, all. Today we're going to look at proportion and inverse proportion, but we're going to look at it in a worded way, basically. So I'm going to do a couple of examples and then love you to just crack on and have a go at some of the questions on the worksheet. If you get stuck, please email me. Okay, I can help you out. So please do whatever you need to do so you can move forward rather than get stuck. Right. So this first example. Let's have a little read of it. The power output P of a car's engine is directly proportional to the square of its speed. So what's nice is they've actually told you that it's directly proportional to the square of its speed. So when the car travels at 60 meters per second, the power output of the engine is 1800 watts. So this M/S is meters per second. Watts is basically your power, which is work done over time. That is pretty much it. So find the power output when the car is traveling 10 meters per second faster. So if we know it's traveling at 60 meters per second, then 10 meters per second faster would be 70 meters per second. So what I need to do is I need to form my equation. I need to substitute in my two values. I need to work out my constant, the k value, the proportional constant, and then I need to form my equation and then use 70 meters per second to work out how many watts the engine will be using, so the power output even of the engine. So if we know it's directly proportional to the square of its speed, then we know P is proportional to the speed squared. Okay, so let's start writing this as an equation. So P equals Ks squared, and K is the number we need to find. So they've given us two values, 60 and 1800. So 1800 is P, so that's 1800. Then we've got our K, and then we've got our 60 meters per second, which is our speed, and we square it because it's the speed squared. So let's rearrange this and let's expand out the 60 squared. So we get 1800 equals, well, 60 times 60, 6 times 6 is 36, with the two zeros, 3600, and then we've got our K. So I just need to divide through by 3600 to find my K value. So 1800 divided through by 3600 equals K. Simplify this equation, so cancel out the zeros. 18 divided by 36, well, 18 is half of 36, so K equals a half. So we basically have the K value now. So I can put this K value back into this equation, and there's the equation that I'm going to use. Okay, so our power is equal to a half of S squared. Okay, so I've just replaced the K by the half. You could rewrite this as P equals S squared over 2. Okay, that's the same as a half. If I divide something by 2, I am basically halving it. Okay, so find the power output when the car is traveling 10 meters per second faster. So we don't know the power yet, but we do know that the speed is 60 plus 10, which is 70, squared divided by 2. So I just now need to expand this out and work out the answer. 7 times 7 is 49 with the two zeros. So 70 squared is 4,900. I want 4,900 divided by 2. Half of 4,900, I think half of 4,000 is 2,000, half of 900 is 450. So the power equals 2,450 watts. Okay, so there's a nice worded example for you for direct proportion. Now let's have a look at one where it's indirect or inverse proportion. Okay, a building company makes affordable housing and has 16 staff members. The 16 employees could build all of the housing in 6 months. So how long would it take 5 staff members, and what assumption have you made? Okay, so let's just break this down, and let's just think about actually the reality of the situation. You've got 16 staff members, and it takes them 6 months. If we had less staff members, 5, would it take more or less time? I think the fewer people that you have, it's going to take more time. So let's just think about this. This is how I know it's a direct, indirect or inverse proportion. So the staff and the time. So the fewer the staff, the longer the time, surely. So the more and more staff that you have available to you, surely the time it takes would get less and less and less. Okay, so because this is a graph that's going down as something increases, so time comes down as something increases, this is an indirect problem. Okay, and we just assume, we make the assumption, well, there's two assumptions, that the rate at which they work is the same, so therefore this is not a squared situation, this is just a normal indirect problem. So the main assumption is they all work at the same rate. Okay, and there's not going to be any squareds involved, so we don't need to worry about that. So that's that bit, is they are all going to work at the same rate. Although in reality you might have some staff members that do a better job than others. So anyway, let's just think about this. We've got staff members, let's call them S. So staff members is S, and time is T. Okay, so we've got S and T. We don't need this graph, but it's basically a demonstration that actually if you have a graph that's going down, that's an indirect proportion or inverse proportion. If you have a graph that's going up, that's a direct proportion. Okay, so we have an indirect inverse proportion here kind of problem. So we know that the time taken is proportional to 1 over the staff. Okay, so let's write this as an equation. So time, the time it takes, the constant on the top, which we need to work out, and the number of staff on the bottom. Now they've told us it takes 6 months for 16 employees to build this house. So the time taken, 6 months, and the number of employees is 16. So I just need to rearrange this, and then I can get my k value. So if I times both sides by 16, then I get 96 equals k. So we've got our constant. Okay, so we can write that in our equation, and then we have something that we can use. So the time it will take is equal to 96 divided by the number of staff. So how long would it take 5 members, and what assumption have you made? So if there's 5 members, then the time it takes is 96 divided by 5. How many 5s go into 96? Well, there's 19 in 95, so that's 19 and 1/5, which is 0.2. Okay, so the time it takes is 19.2 months. The assumption we've made, all the staff work at the same speed. Okay, and then it won't affect that equation at all. Right, there's a couple of examples. If you get stuck at all with any of the work that I've sent you, please send me an email. All right, I can help you out. I can do a little video or something. Maybe go through the question for you. All right, but give it a good go first yourself. All right, good luck. Have a good day.